Imagine floating in the inky blackness above Earth, suspended like an astronaut in the silent void of space. The only sound is the hum of your life support, a stark contrast to the profound quiet surrounding you. Below, our planet glows, a vibrant sphere of blue and white, a beacon of life in the cosmic darkness. It's a breathtaking view, a reminder of the unique and precious nature of our home. It's a swirling marble of oceans and clouds, a dynamic and ever-changing canvas painted by the forces of nature. Weather systems dance across its surface, creating intricate patterns that shift and evolve in real time. But look closer. Past the swirling continents and ephemeral clouds, begin to peer beneath the surface, beyond the familiar landscapes we know so well. And you'll see immense cracks, subtle yet profound, etched into the very surface of our world. These aren't imperfections, they're stories written in stone. These are not rivers carving their way to the sea or coastlines sculpted by the relentless waves, but scars, deep, enduring marks upon the face of the earth. Vast fissures that reveal the restless power churning beneath our feet, a hidden world of immense energy and constant motion. They are a glimpse into the planet's inner workings. They stretch for thousands of kilometers, like geological highways etched across continents, testaments to the immense forces at play. They mark the seams where Earth's crust is torn apart in slow motion, or mashed together with unimaginable force, a constant cycle of destruction and creation. From orbit, these cracks are more than just lines on a map. They're the planet's storybook, a geological narrative written in rock and fire, telling tales of ancient upheavals and ongoing transformations. The San Andreas Fault, that infamous fracture in California, appears as a delicate incision, a subtle reminder of the potential for dramatic shifts. The Great Rift Valley in Africa, a colossal gash across the landscape, appears as if the planet is slowly unzipping itself, revealing the raw earth beneath. These aren't just geological curiosities, interesting patterns to observe from above. They are fundamental forces shaping our world. They shape where oceans form, carving out vast basins over millennia, where mountains rise, pushed skyward by immense pressure, and even, incredibly, where life began, in the hydrothermal vents along these very cracks. Our world is not static, not a finished product, but alive, dynamic, and constantly changing, evolving before our very eyes, albeit on a timescale that dwarfs human perception. These cracks, these scars, are the visible signs of its pulse, the outward manifestation of the planet's inner life. They represent the slow, inexorable rhythm of geology that shapes everything we know, from the continents we inhabit to the resources we depend on. From space, the sheer scale of these features is breathtaking, a humbling reminder of our place within this grand, geological drama. A mountain range, a colossal barrier on the ground, becomes a single, elegant line, a delicate brushstroke across the face of the planet. The ground beneath us is not the solid, immutable foundation we often assume it to be, but a mosaic of moving pieces, a constantly shifting puzzle of tectonic plates grinding against each other. Earth is a work in progress, a planet perpetually under construction, never truly finished. Its giant cracks are the brushstrokes of ongoing creation, the marks of a planet constantly remaking itself. They remind us of the immense timescales and the unfathomable forces that govern our existence, putting our fleeting lives into perspective. We live on a thin, fragile crust, a delicate skin stretched over a molten core, perpetually remade from within by volcanic eruptions, earthquakes, and the slow, relentless movement of tectonic plates. From space, the evidence of this eternal dance is both beautiful and humbling, a testament to the power and resilience of our planet. Our planet's scars are not blemishes, but a testament to its power, its history, and its enduring vitality. They are the signatures of a living world, a planet that breathes, shifts, and evolves on a grand scale. And they are visible even from the silent depths of space, a constant reminder of the dynamic forces that shape our world. So what are these scars that etch themselves across the face of our planet? What forces could possibly be strong enough to leave such lasting marks? They're boundaries, the edges of something truly immense. These are the meeting points of massive slabs of rock, colossal pieces of Earth's outer shell called tectonic plates. These plates are not static, they are in constant, albeit slow, motion. Earth's surface is like a cracked eggshell, but instead of a fragile shell, we have a dynamic, ever-changing crust. This shell is broken into a dozen major plates, like the Pacific, North American, and Eurasian plates, and many smaller ones, each interacting with its neighbors in complex ways. The cracks, faults, rifts, trenches, these aren't just random imperfections. They are the direct result of the interactions between these plates, the places where these plates meet, grind, and otherwise interact, shaping the world we see. Sometimes plates pull apart, driven by forces deep within the earth. This divergence creates rifts, dramatic valleys like Africa's Great Rift Valley, a place where the continent itself is slowly being torn apart. It's here, in these rifts, where new crust forms as magma rises from the mantle, solidifying and adding to the edges of the separating plates. Other times, plates collide head-on, a monumental clash of geological titans. This collision can result in the crumpling up of mountains like the majestic Himalayas formed by the ongoing collision of the Indian and Eurasian plates. Or, in other instances, one plate plunges beneath another in a process called subduction. This subduction creates deep trenches like the Mariana Trench, the deepest point in the world's oceans. And sometimes plates grind past each other horizontally, neither colliding nor diverging but sliding. A prime example of this is along California's San Andreas Fault, a major transform boundary. These boundaries in all their forms are where the planet's most dramatic and impactful changes happen, shaping the world as we know it. Divergent boundaries are the birthplaces of new land, constantly adding to the Earth's surface. Convergent boundaries, on the other hand, destroy old crust as they build mountains, recycling the Earth's surface. Transform boundaries, with their immense friction, unleash earthquakes, sudden releases of pent-up energy. These earthquakes occur as plates stick together for extended periods, building up stress only to slip suddenly, sending shockwaves across the globe. The San Andreas Fault is a classic example of this process, a place where tension builds and releases in dramatic fashion. It's a place where the Pacific Plate relentlessly slides past the North American Plate, a slow-motion collision with explosive consequences. These cracks, these boundaries, are more than just lines on a map. They are the architects of our world, constantly reshaping the landscape. They are shaping its surface, influencing its climate, and ultimately, writing its story, a story billions of years in the making. They are the restless seams of a living planet, a testament to the powerful forces that continue to mold our world. What drives these colossal plates? Heat. Earth's core is hotter than the surface of the sun, warming the mantle beneath the crust. The mantle, though solid, flows slowly, like hot asphalt, creating convection currents. Hot rock rises, cools, and sinks, dragging the plates along in a slow-motion conveyor belt. This is plate tectonics, the grand unifying idea of geology. It explains earthquakes, volcanoes, mountain building, and drifting continents. The plates move at the speed your fingernails grow, but over millions of years they reshape the world. When we see a crack like the Mid-Atlantic Ridge, we're seeing the surface expression of this deep, hidden engine. Our planet is a dynamic system, recycling its crust, driven by ancient heat. Let's visit the Great Rift Valley, one of Earth's most spectacular cracks. Stretching over 6,000 kilometers, it's where the African continent is being torn in two. The crust stretches and thins, blocks of land drop down, and steep cliffs rise along the edges. In a few million years, the Indian Ocean may flood in, splitting Africa and creating a new island. The valley's unique environment fostered the evolution of our earliest ancestors and preserved their fossils. Volcanic giants like Kilimanjaro and deep lakes like Tanganyika are born from this rifting. The Great Rift Valley is a living laboratory where geology and biology intertwine. It's a testament to the immense forces shaping our world and our origins. Now, we turn our attention to one of the most famous geological features on the planet, California's San Andreas Fault. This massive fracture in the Earth's crust is more than just a line on a map. It's a dynamic boundary where two of the planet's largest tectonic plates meet and interact. It's a crack defined by sideways motion, a constant creeping dance between colossal forces. Here the Pacific Plate, a vast expanse of the Earth's lithosphere, relentlessly grinds northwest. It's a slow but unstoppable journey, measured in centimeters per year. This movement occurs past the North American Plate, the continental landmass upon which much of North America rests. This creates a 300-kilometer scar, a visible testament to the immense power at play beneath our feet. This scar stretches across the California landscape. The plates don't slide smoothly. Instead, they engage in a stop-and-go struggle. They lock. Pressure and strain builds relentlessly over time like a coiled spring, and when the accumulated stress exceeds the strength of the rocks, it snaps, and earthquakes erupt with devastating force. The infamous 1906 San Francisco quake, a cataclysmic event in California's history, was caused by just such a rupture, a sudden release of pent-up energy. This shifted the ground by meters in mere seconds, a violent jolt that reshaped the landscape and the lives of those who experienced it. The San Andreas is the main artery, the dominant feature in a complex network of interconnected faults, a web of geological instability. This intricate system makes California one of the world's most seismically active regions, a place where the Earth is constantly in motion. These faults have shaped California's dramatic scenery, sculpting the land over millions of years. They've created long valleys and coastal mountains, defining the state's unique and beautiful topography. But they're also a constant reminder, a stark warning. The ground beneath us is restless, alive with geological activity. The San Andreas Fault is a living, moving boundary, a place where the Earth is constantly reshaping itself. It's a powerful symbol of Earth's ongoing transformation, a reminder of the immense forces that shape our planet. Dive beneath the Pacific to the Mariana Trench, the deepest crack on Earth. Hidden under kilometers of water, it plunges nearly 11,000 meters below sea level. Here, the Pacific Plate dives beneath the Mariana Plate, creating a chasm and recycling old crust. Despite crushing pressure and darkness, life thrives. Strange creatures adapted to the extreme. The trench is part of a dynamic system. Subduction releases water, melts mantle rock, and fuels volcanic eruptions. The Mariana Islands are volcanic peaks born from this process. The trench is not just a deep hole. It's a site of destruction and creation, a window into Earth's cycles. It shows life's tenacity and the planet's relentless change. The Mariana Trench is a profound reminder of Earth's hidden power. Beyond the famous cracks, Earth is etched with many more. In Siberia, Lake Baikal sits atop an active rift where Asia is slowly splitting apart. The rift is widening, earthquakes are frequent, and the lake fills a deep continental depression. If rifting continues, a new sea could one day form in Siberia. The East African Rift is another dramatic example, with volcanoes, lava flows, and deep lakes. The Mid-Atlantic Ridge marks where continents pull apart beneath the ocean, surfacing in places like Iceland. In New Zealand, the Alpine Fault is a transformed boundary, echoing California's seismic story. Each crack tells a chapter of Earth's restless, dynamic history. These cracks are more than geological features. They're engines of change. Volcanic activity at plate boundaries released gases that formed our atmosphere and oceans. Hydrothermal vents, born from these cracks, may have incubated the first life on Earth. Plate movement drives evolution, creating and destroying habitats, isolating species and forging new ecosystems. Fertile volcanic soils, mineral riches, and geothermal energy all come from these restless zones. But they also bring hazards, earthquakes and eruptions that shape human history. These cracks are sources of creation and destruction, wealth and risk. They shape not just the planet, but our own story. From space and time's grand perspective, nothing on Earth is permanent. Continents drift, mountains rise and fall, oceans open and close. The cracks we see are proof of this constant motion. Plate tectonics revealed our world as a living, interconnected system. This change will continue. Oceans will widen or shrink, continents will split or collide. In millions of years, the map will look entirely different. We are witnesses to one frame of an epic, ongoing story. So, when you see a map or a photo of Earth, see the motion, the breathing, the cracks. They are not flaws, but signs of a living world, always remaking itself. Our planet's scars are the signatures of its magnificent